Happy New Year, everyone. Welcome back. I've been running my electrical harness into the car, so I'm going to show you how I've done that. At the same time, that's meant that I need to install my shifter cables, my brake lines, my clutch line, and a few other things. So I think that'll be sort of useful to see how that comes together. I'll talk about brake lines in terms of why you might want to use PTFEs, such as I have, instead of hard lines, the advantages, disadvantages. With the electricals, I'll talk about some of the clips that I'm using, some advantages, disadvantages to that sort of stuff. I've also had my alternator turn up. This has been a bit of a saga, just trying to get one that would do the job in terms of having an idle output amperage that was sufficient to drive everything, but then balancing that with not overspeeding the alternator at its red line. There can be a bit of an issue there, apart from warranty. The things like to throw bearings, and also the stator will hit the housing and cause you a bit of trouble. So I'll run over all of that and give you a bit of a template so you can size your electrical load, so you can purchase the right alternator, and just having a quick look at alternator curves and that sort of stuff, so you can make the right selection there. Hopefully that'll be helpful. I'll also run over the wiring of those things, because that can be a bit tricky if you're doing any sort of custom build where you're doing an engine swap or something like that. I've also got one of these Raptor controllers which I'm going to give away when I install the steering and put this steering wheel in place. I'll talk about how I wire it at that time. It is a really awesome bit of gear. They are full motorsport spec sort of controllers that you can run into your car. I'm thinking about buying one for my race car, but Summit Technologies have sent me one to give away. So, share your build and what you would put one of these into in the comments. I'll select one that I think it would be especially suitable for. Otherwise, obviously, as usual, if you have any questions, let me know. If there's anything you hate, let me know as well. I'll try and get some of that really awesome royalty-free music in for any of these time lapses that I do. I'll try and select something that is a bit less shithouse than the last one, but it's a bit of a time vampire to search something out there. So if anyone has any good music, I'm more than welcome to put it on. Anyhow, look, we'll get into it, and hopefully you enjoy it. Thanks. So there's the wiring loom just loosely draped over the chassis. What I need to do now is just start working front to rear. The first option is just to get the main junction points in position, and probably just hold them in place with zip ties, just like these ones here, holding that battery cable. Ultima have a pretty good description on their set of instructions in their build manual for this, that just shows cable routes, mounting positions, and also a bit of a key for what you're actually mounting there. There's some photos as well, which are always useful, just to give you a bit of an illustration for what they're talking about there. Otherwise, it's just making sure everything's in position. I'll have to do this same process for my engine side loom, but I'm building that, so there'll be a level of familiarity and stuff with that loom that's probably going to be somewhat helpful to me getting everything in position. Given that I'm building it as well, I'll also have to make sure that I get all those lengths right. I'll work through the process for how I've attacked that in another video. In itself, it's quite a big job. The other option, of course, is to just go with the standard GM loom. You can buy them off Summit in the US or someone like that, and you can run a standard ECU. I just like the aftermarket ECUs because of the flexibility they sort of provide, and also the tunability. You get the most out of your power plan and drivetrain potentially. I'll just explain a couple of the fixings that I'm using here. These are Hellman Titan ratcheting P-clips. Obviously you can feed the wiring loom through there, and then they just ratchet up and sort of fit to the size of the wiring loom. They're available in a variety of sizes. The advantage being that you can, if I don't stab myself in the hand here, reuse them just by undoing them with a small screwdriver like that. And particularly, for example, under the dash area where I want to be able to maybe in the future run some additional cables, I can still do that, maintain the existing wiring routes, and do that all neatly, and it does kind of fit to the size that you want. So that's just a really good bit of gear. I'm probably going to chop that off and just use this mounting point here under there, just to keep that simple. They're available with L brackets and all sorts of stuff. I can't remember exactly where I got them from. They're not that cheap, but for a few select places, really important. As I say, having that sort of future-proofing is really important, and if you can have any of the mounting things that'll provide sort of dual functionality, it'll keep things a lot neater. Here's a little battery clamp that there's a mounting point in the side that'll go into the bulkhead here that I'm going to use, and you can see I've just integrated a couple of wiring guides there. I always think having that sort of dual use always keeps things more elegant and sort of gets rid of a whole heap of nonsense and rubbish that you end up having in. I mean, if I can do that, it means that I don't have to have additional P-clips and that sort of stuff, which is going to make this all look rubbish. So those sorts of things make sense. If you want people who have I made use of that previously in industry. You know, Porsche 917s used to run oil in their chassis tubes, which meant they didn't have to have additional reservoirs, which saves weight and all these sorts of things. The fact that they made the chassis probably too light that they were susceptible to braking is a little bit of a different story, but leave that as it is. You know, Eric Buell used to do the same thing with their Buell motorcycles. I mean, apart from not having probably the best power plant, they might have been a success story or gone the other way. Anyhow, that's just some of the things that I'm doing just to make this serviceable in the future. And also, you know, as neat of an install as I possibly can. I'm not doing any fancy wire tuck stuff, particularly this wiring loom that runs outside here. I probably would have preferred that was encased in sort of, you know, a Raychem type, you know, insulation that's like basically a really heavy duty shrink wrap, and they were all sort of, you know, properly weather sealed. But, you know, you have to pick and choose your battles in that sense. My original thing for this is I would have liked to have built my whole wiring loom myself, but it just seemed like too large of a job and probably a bit outside of my area of expertise. As it transpires, I'm going to end up being, you know, probably balls deep in the engine side wiring loom, a lot more than I ever expected to be, but be that as it may, it'll be a good learning experience, even if there is a bit of resistance from me at the start. So yeah, look, there's just a couple of things. If you have any questions, of course, throw them down below. If you do see anything that I'm using and you want to know where they came from, let me know, and I'll see whether I can find out, you know, dig up my receipt for it and send it through. These things can all add up in terms of cost as well. There's always the things that people never sort of think about when they're building their car. So having an allowance for those, you know, I expect in this car it's probably going to be in the order of maybe $5,000 or something like that by the time I take these things into account, and, you know, stuff like AN hoses and whatever else. So, you know, if you are going to attack these, I think you need to be at least somewhat honest with yourself about the costs. Probably don't be honest with your missus if you don't have one that's understanding. Luckily I do. Right, so as you can imagine, I'm sitting in the rear here where the motor's virtually going to be sitting, and we're going to be installing these clips here, which are going to retain the wiring loom that runs along the rear of the bulkhead, so I can zip it in there. The reason that I'm using these clips, particularly along this bottom section here, is I've got the factory loom that I've got to install, but I also want to be able to run my engine harness along the back here once I built that to feed the coils that are going to be sitting on this side of the motor to the V8. Now, what I've had to look at here, and the reason I've got my laptop set up, is because there's a whole heap of other things that are going to be mounted to the rear of this bulkhead. And if you don't look far ahead there, what I'm likely to do is to mount these clips in a position that's going to conflict with, say, the fuel pump that gets mounted here, or... Right, camera fucked out. Is this going to fix it? Yeah, sort of fixed it. Anyway, it's likely to conflict with the fuel pump that gets mounted here, or or the swirl pots or anything else that gets put in place. The other thing that would be really annoying is to have rivet lines or these mounting lines not being level across the back here, and it just sort of look like a bit of a sporadic mess. So it's difficult to obviously be able to look this far ahead in all instances. I'm sure there's going to be a mistake somewhere on the build. But, you know, being able to spend a bit of time now and just try and look as far ahead as you possibly can is going to pay some dividends in terms of the quality of the way things look at the end. So look, that's how we're going to do it. I'm going to need to be a bit of a contortionist working in the back here, but such is the fun of building this. One of the greatest sources of frustration with electrical stuff is having poor earths. Just because you can end up with intermittent readings, it's not necessarily a consistent fault, which makes it difficult to track down. So here's just one of the earth points. There's half a dozen of them on the chassis, and what we're going to do is just buzz it with the Dremel here. I've already reamed out the center, just using a file to ensure that we get good mechanical contact between your electrical connector and the chassis itself. That's pretty much it. The other thing you can do is, if it is in a situation where it's going to potentially cop a bit of corrosion, just hit it with a bit of dielectric grease, and that'll ensure that it doesn't, you know, develop a high resistance over time. So there are the master cylinders there. The two on the left are the front on the far side, and then the rear in the center, and then there's the clutch master on the left hand side. In a normal car, what you typically have is that you would just have a single master cylinder, and you'd have some brake bias adjustment incorporated into the system, just a hydraulic bias adjuster, whereas obviously here we've got that balance bar that sits on the brake pedal there, you can see on the bottom, which enables me to adjust the screw there to the left or to the right, so that I can give more braking at the front or more braking at the rear. This is more of a race car style setup, because you do aim to sort of muck around with this when you're at the circuit to optimize your braking. Ideally what you want is, in every situation, you want your fronts just to lock in advance of your rears, especially in a car like this. If you were driving along and you had too much rear bias, what you do is you'd lock the rears, and you'd find that you are in the fence pretty quickly. If you want an analogy to that, it's kind of like pulling, the handbrake turns you used to do in the Macca's car park in your mum's car when you were learning how to drive. Anyhow, obviously solid lines are ideal for a number of reasons. They don't flex at all, but they're infinitely more expensive to install. They need to be bent properly using a brake line bender, and they need to be fitted off very carefully to make sure that you're using the right flaring tools. There's a whole number of different flares that you need to use depending on what style of braking setup and fittings you're using. That topic is probably a much larger topic that I probably won't cover on this car. The car that I'm building after this actually does have solid lines, so I'll cover it on that in a later date. But the one thing with this PTFE hose, or even the non-nylon coated stuff for the clutch slave, is that each size of hose will actually have a minimum bend radius, and that's so that you don't create an oval crushing in the line itself, or even worst case, you can create a pinch in it, and then you won't have any braking. Particularly when you're concealing lines like we are here, that can be a bit of a nightmare to come back to. I've used some metal P-clips here in comparison to the standard nylon jobs. The reason for that is that I can just sort of use this for some fine adjustment. I can just bend the metal P-clip, and it'll at least hold the line in place. And what that's enabling me to do is just ensure that I get smooth bends in all this sort of stuff. I mean, this is quite a small line. I think its minimum bend radius is about 50 mil from memory. It is dependent on the type of hose and what size it is. So just one of those ones to keep in mind. As you can see, the insulation's in there, and I've got the feed, or return in this case, for the heater core. As we run down here, there's not too much more to look at. I've got to fit all this stuff off. I've run out of P-clips because there weren't enough supplied with the kit, so I will get to that. Typically what you'll have in a lot of systems would just be a brake light switch. This is just a pressure switch that basically completes the circuit and enables you to turn your brake lights on. You can get really terrible ones of these, and they can be a pain in the ass, so whatever you're doing, just make sure you buy a quality component. The other thing that can be useful to install right now would be just basically some fittings like this, and sort of like the brake light switch, but it enables you to just put in a pressure and temperature sensor that you can run back to your ECU for data logging. Like I say, if you are having braking problems, that can tell you a lot just by having a pressure sensor on the front and back brake circuit, just so you can work out what's going on, potentially whether you have a brake fault, or even if you have a particularly faulty brake caliper, or a number of other things. So that's something really worthwhile having. It's also nice to be able to look back if you're trying to improve your times. You can go back and look at your brake force and see whether you're actually pulsing the pedal when you're heeling and towing, for example, and that's sort of unloading and loading the car, and that's why you're braking traction and running into trouble. Anyhow, that's a bit of a rundown on that. Right, so this is a shifter and handbrake cables, and I just measured with the calipers to see what the size of this thread was. It has to go through here for the handbrake feed, and it's about 1.5 mil short. So I just reamed out the paint there. I think it was just the powder coating finish that was the difference, but I'm actually just going to have to drill this out by about another mil, so that can feed through there. One of the things you need to look at when you're doing this is just making sure that whatever your arrangement is here, if you have a similar setup, make sure that there's no chance that you can suffer interference between the two systems. You don't want to get entangled up. You don't want a gear shift or something like that sticking at the wrong time. Having that sort of thing, if you are on a track or driving particularly fast, you can run into a situation where you unsettle the car because you don't have the right, because you've missed a gear or something like that, and you unsettle the car and have a lift off oversteer moment or something like that. So it's just something to I guess try and avoid if you possibly can. I mean, things do go wrong, but while you're here and you can actually make concessions to make sure that you don't have any interference, it's really a good idea, even if it's a zip tie or something like that, just to make sure that it doesn't get in the road. Right, so we just need to feed these rubber grommets over these shifter cable and handbrake cables. The one thing that I can recommend with these is if you buy crappy ones, say off eBay, they're a bit plasticized, so they like to break apart as distinct from actually slide over. Bit of lubrication helps. Otherwise, you're pretty much doing, if anyone's seen Ace Ventura, where he gets birthed out of that rhinoceros, you're pretty much trying to play that game. They do stretch. It's always good to have a spare one. I don't, so I'm hoping I don't rip one of these in half. But otherwise, we just feed it over the cables, and then it goes into the firewall. We're going to do the same on the other side, and that's going to seal it. So here's my 220 amp PowerMaster alternator. It is available as either an OEM hookup or a single wire hookup. Now, what you need to know about that, which is beyond just the fact that it spins and creates electricity, is a single wire connection means that it is self-exciting. It means that it doesn't need any more than a wire from the battery to the single post on the alternator to charge your battery and keep everything happy. Where this differs from lots of other alternators, particularly that you would find in most OEM applications, is that they require either an ECU connection or a load such as even a globe to be connected to it to excite the alternator so that it will start to produce current. This one here can still be hooked up as an OEM application to GMs, but the fact that it has a single wire connection is really going to suit me because I can just run that single double BNS cable from the alternator to the battery and move on with life. Now, when you're looking at buying an alternator, what you need to do, and this is on the PowerMaster website, you can also get it from lots of other places that do it. There's just a tabulated list of all of the items in your car, whether that is, radio systems, fans, lighting systems, all sorts of stuff. This one even has cooling suits and lots of other stuff that are more suitable to race car applications. You need to tabulate all of those up, look at your maximum current draw, and then you will need to look at what your losses are in the cable, such as if you want to look back at the last video I did, that talks about that and gives a good guide on it. And then that will give you an idea of what sort of output you need your alternator to give. Then beyond that, these typically are rated to about 18 to 20,000 RPM shaft rotational speed as a maximum. If you exceed that, it's beyond the bearing ratings and a few other things, so they do stand to shit themselves. Even bits within the rotator will start to hit the housing. So it's not exactly the best idea. This pulley here is typically about 1/3 the size of the pulley that's going to be on your crank. So if your crank's rotating at 1,000 RPM, this pulley will be rotating at 3,000 RPM. Now, when you get the rating on most alternators, you'll see that it says here 220 amps. Great. I need 170 amps, say. That's great. The only problem is that this 220 amps, if you look at, and this isn't for this alternator, but it is for an alternator, alternator curves, typically the alternator is rated at its 6,000 RPM point. Now, that's not very useful when you are really most concerned about when you're sitting in the dark with the aircon running at full tilt and all your lights on and you've got the stereo pumping, because even though, like for this alternator here, it is a 160 amp rated alternator, it is only going to be producing potentially 80 amps or less when you're sitting at idle at, say with a standard LS, like my LSA in the Ute only idles at 550 RPM. So you're going to be struggling to produce much out of that alternator. But this one, at idle, or rated idle, is 150 amps. The other thing that was good about these PowerMaster ones is there are a range of pulley diameters that you can select from to choose, or even if you retrospectively wanted to change because you've raised the rev limit in your car or whatever, just to ensure that you're going to be spinning this hard enough to produce the current that you need, keeping in mind that your red line is also going to need to be appropriate to not overspeed this thing. I'm going to be fudging the numbers a little bit here. At the top end of my rev range, I will be exceeding that, but it's only going to be for a few moments, and it's probably going to be, not too often. So I'm not too worried about that. So that's basically how you need to select your alternator. Beyond that, I looked at the DC power options. They were about $1,300 Australian landed here. This was $650, and the only difference in my mind is that this had a better catalog in terms of selectability. The DC power guys got back to me pretty often, but their shipping was $160 to Australia, which was a joke. And I don't really care about billet housings because I don't know, I prefer things not to be a show pony. But if you were doing a street rod or something like that, I assume that might be well worth the money. Otherwise, I spoke to a number of auto elects and they didn't know their product, especially in Australia. We just have a lot of guys who are pretty much parts replacement warriors. They don't actually know their product, how it works, or how to deal with anything out of the ordinary. VPW in Melbourne didn't have a product. Outlaw Speed Shop in South Australia did. They've been quite good. Rocket Industries I just couldn't get onto in Queensland, so that was a waste of time. And the 2 or 3 auto elects, like I said, I spoke to locally, they had no idea, as far as they were concerned, unless it was a replacement alternator for another GM product that you can just pull out and plug in a new one. They weren't able to deal with it. Anyhow, look, that's alternators in a nutshell. Obviously, I could go into the reasons why you know alternators require some current and things to excite them so that they'll deliver, but look, that's probably beyond the scope of this. You can do a bit of Googling, or if you want to ask any questions, you're more than welcome, and I'm happy to respond in the comments.